Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Okay, today is tutorial class, so I would like to discuss some questions regarding chapter 2.2 logical equivalence. Let's turn to page 75, exercise 2.4. Okay, we will do exercise 2.4. Okay, I will discuss some questions in exercise 2.4. Question number 1: if it is raining today, then I will not go to school. Okay, this question is to find logical equivalence statement. So the given statement is conditional statement. So for conditional statement, the only statement that equivalent to that conditional statement is its contrapositive. So before we get the contrapositive, so let's define the simple statements. So here in this conditional statement, there are two simple statements. Okay, I would like to define as P. For first simple statement, it is raining today. It is raining today. Okay. Next simple statement defined as Q. I will not. No, I will go. Take the positive statement. I will go to school. So this conditional statement in symbolic is P implies not Q. Right. So now to get the contrapositive, okay, logical equivalence statement is its contrapositive, not Q implies not P. Okay, remember the form of contrapositive, just like here, the important form of contrapositive. So P implies Q is equivalent to its contrapositive, not Q implies not P. And also we also should know that double not P is equivalent to P, right? So this one is equivalent to Q implies not P. So write in English sentence, if Q I will, if I will go to school, then it is not raining today. Okay, so next one is to get the converse of this conditional statement. So remember the converse P implies Q, its converse is Q implies P, right? So follow this form, Q implies P. So conclusion become hypothesis, right? So not Q implies P. So write in English sentence, if I will not go to school, then it is raining today. Okay, done. So next question C, to get the inverse. So what is the inverse? Okay, let's look at the previous one. Inverse not P implies not Q, right? Not P implies not Q. So this one equivalent to not P implies. So you should simplify. Don't just leave like this, because we have here not is equivalent to not Q equivalent to Q. Right? Is equivalent to Q. So now translate this in words. If it is not raining today, then I will go to school. Okay. Lastly, to find the negation. Right? So the original statement in symbolic P implies not Q. So now to get the negation, just put that negation. Right. The translation, okay, the P implies not Q is equivalent to, okay, remember this formula, P implies Q equivalent to not P or Q. Right, so let's follow this formula. Not P or not Q. Right, and then simplify this, open the bracket, not P, okay, or change to not Q. So this one equals to P and Q. Translate into a sentence, translate into words. So what is P just now? It is raining today, right? This symbol you can use and or but, either one, either one. You can use either and or using the word but. And I will go to school. Alright, so we finish question 1. So next is question 3 that I would like to discuss. Okay, using the word only if, only if. Right, first of all, as usual, we define the simple statements in this given statement. Right, there are two simple statements. Let me define as P for first simple statement. I work extra. Okay, I work extra hours. I work extra hours. Q, I will get extra income. Okay, so the given statement in symbolic is P implies Q, right? P implies Q. So to write inverse of converse. You see that this is two words here, inverse of converse, meaning that you should find what is the converse of this statement. Find the converse first. Converse of the statement is Q implies P. And then inverse of this symbol. So inverse of the converse, inverse of converse. Or you can write as inverse of this symbol is inverse of this symbol is not Q implies not P. Alright, so write in words if not Q. If I do not, if I don't, or if I do not, if I don't work, if I don't get, sorry, Q, not Q here, not Q. If I don't get extra income, then I don't work extra hours. Contrapositive of inverse. So get the inverse first. What is the inverse of this statement? Inverse of this statement, not P, implies not Q, right? So then we can find the contrapositive of not P implies not Q. So what is it? Contrapositive of this statement, not Q implies not P. So this one you can simplify. This is equivalent to Q implies P. So write in words, if I will get extra income, then I work extra hours. Right. So finish question 3. So now we go to next question. So I choose question 5. Okay, question 5. If I'm happy today, I cannot see the question. Okay, if I'm happy today and I wake up early, then I go for cycling. Okay, if I'm happy today and I wake up early, then I go for cycling. Alright, that's the given statement. Now question A, state the implication by using is sufficient for. Right? So first of all, of course, you write the simple statement first. So let me write here as P, I'm happy. I'm happy today. Q, I wake up early. R is I go for cycling. Okay, I go for cycling. So the given statement is in symbolic is what? P and Q. You should put bracket, implies R. Okay, so now let's go to this. By using is sufficient, the word is sufficient for. So is sufficient, I'm is sufficient. That means this one, okay, is sufficient for I go for cycling. Alright, so you should write I'm happy, I am P and Q, I am happy today, I am happy today, and I wake up, P and Q, and I wake up, and I wake up early, is sufficient for I go for cycling. I go for cycling. Okay. When you use is sufficient for, alright, before sufficient is hypothesis, alright, and okay, after sufficient is a conclusion. So this one we act this as hypothesis, right? This one we call hypothesis. R is a conclusion. Okay, conclusion. So state the converse of A. So here this statement is translate similar as the given statement. P and Q, right, implies R, right? So to write the converse of A, converse should be R implies P and Q. Okay, so write in words. If I go for cycling, if I go for cycling, then, right, you see that this word and, and so you can use this symbol is n for n, this symbol is for n. All right, when you write statement in words, all right, when you write statement in words, you can use a word both, then both um, p not both, okay, never mind, this one no need to do both, it just straight away I just translate into I am. If I go for cycling, then I'm happy, then then I am happy, then I'm happy today, and I wake up early, then I wake up early. All right, so finish all right, see, you got here CD, CD, state the implication as disjunction. Okay, just now what is the implication? Okay, this implication as disjunction. Let me copy P and Q implies R. We got that statement P and Q implies R. State the implication, that means this implication as disjunction. So this question means to write the equivalent statement for this implication statement, right? This one is equivalent to, okay, you should change to disjunction, not P and Q or R, okay, or R, like that. Next one, all right, write in words, I'm neither, you can write the words, you can all right, translate this as not P or not Q. I'm not happy today, or I do not wake up early, or I go for cycling. Other way to translate this, let's say I don't want to open the bracket, I just let this symbol not outside the bracket, so the it is not true, you can write as it's not true that that I'm happy and I wake up early, or you can write neither, okay, it is not true, just right here, it is not true, it's not true, I'm I I'm it's not true, I'm happy, and I wake up early, or it is not true, I'm happy and I wake up early, you should put comma, or I go for cycling. Okay. So next one, state the negation of implication as conjunction. Right, you want to state the negation of this implication, right? So you should write this way. Okay, copy the implication statement. Okay, and then to get the negation, so I just put not outside the bracket. Okay, let's simplify this statement. Okay, we know that implication statement can be written, rewrite, and you can rewrite as its equivalent statement, not P and Q or R. Okay, or R. So and then I would like to open this bracket, and then not will be inside, put inside P and Q. And what happened, this not, when it come to O, it will change to N by using De Morgan, right? Not R. So this one, this is equals to, not is equivalent to P and Q, okay, and not R. Okay, that's it. Conjunction. State the negation of implication as conjunction. Yes, this one conjunction. This conjunction. So translate into words. Neither. I can put here neither. I'm happy. Neither I'm happy. Neither. Okay, neither. Neither. Oh no. I'm happy neither. Oh no. This one wrong. I'm happy. This one. Okay, no, not here. I'm happy. I'm happy and I wake up early. I'm happy. I'm happy today. There's one word there. I'm happy today. And I wake up early. And I wake up early. And you should put bracket. And I do not go. I do not go for cycling. I do not go for cycling. Okay. So we finish question 5. So go to next one, question 7. Question 7, given in symbolic, not P implies Q. Now write in symbolic form, converse. So converse is Q implies not P, right, in symbolic. Okay? Contrapositive, not Q implies not P. So in this one, you can simplify to not Q implies P. Inverse, not P implies not Q. So this one also you can simplify to P implies not Q. Okay, I hope you understand the solution. So next one, question number 9. So question number 9, I just pick some. A, B, E, right? Fill in the blanks with converse, inverse, and contrapositive. So let's read together. The inverse of what? Of not Q implies P is the converse of Q implies not P. The converse of, what is this? The converse of something of not P implies Q. This one should be the inverse of converse. Okay, let's try converse first. If you put here converse, let's do this. If the inverse of converse of this. Yes, this is true. the inverse of converse, inverse of this. Okay, so get the converse of this one. You will get converse of this is what is converse of this statement? Is P implies not Q, right? Okay, the inverse of this, what is the inverse of this? Inverse not P implies not Q, so Q, right? Is the converse, yes, is the converse, so converse Q implies not P, yes, so this one is correct. Okay, you try and error to get the answer. So next one, the inverse of the converse of this. So let's find what is the converse of P implies Q is Q implies P. So the inverse of Q implies P. The inverse not Q implies not P. Okay, is the what? So this one, take this one. Relationship between this and this. P implies Q. Is the contrapositive. Right? Is the contrapositive of P implies Q. Next one, the contrapositive of inverse of this. So what is inverse of this one? This statement, inverse, not P is P implies not Q. Contrapositive of this, not Q, which is Q implies not P. Alright, not P. Okay, not P. Alright. Is the relationship between this and this? What is that? Is the inverse, right? Is the inverse. Is the inverse of this. Okay. So next question 11. The effects of COVID-19 will be mitigated if governments act quickly. If the effects of COVID-19, this question is to find the equivalent statement, which one that equivalent to this statement. The effect of COVID-19 will be mitigated. So see that the word if in the middle, so that means before if should be conclusion. So normally I will use Q as conclusion and P as hypothesis. So after P should be hypothesis. So P is governments act quickly. We should write in words. What is P? Okay, translate. You should define P. P. Okay, you write the words in full, and then Q write in full. What is P and Q? Then this statement you should translate into P implies Q, right? The translation in symbolic for this statement is P implies Q. Now, to find the equivalent statement, if the effects of COVID-19 are mitigated, then governments have acted quickly. This one, if the effects, this is now the effects of COVID-19 are mitigated, become hypothesis, isn't it? This one become hypothesis. Now this, right? The simple statement for A, P is the effects of COVID-19 are mitigated. Right, mitigated. So Q, governments have acted quickly. Government have acted quickly. Quickly, right? So this one is P implies Q, right? For the given statement, for the given statement, okay, let me re-explain this question. Okay, let me re-explain. The effects of COVID-19 will be mitigated if governments act quickly. So, as I said, before if is the conclusion, and after if is the hypothesis. So for this given statement, P is defined as government, okay, act quickly, right? P is defined as government act quickly. So let me this one cancel this, right? The given statement for this is P, governments act quickly. So you write government acts quickly, right? Government, okay, blah blah, acts quickly. Then Q is the effects of COVID-19 will be mitigated. Okay, the effect of COVID-19. Okay, let's continue this one. I should write P as a government. Governments act quickly. Okay. Q as the effects of COVID-19 are mitigated. Right. So the given statement is in symbolic is P implies Q. Right. P implies Q. But A, if the effect of government of COVID-19 are mitigated. So can you see this statement? If P, this one is Q, right? The effects of COVID-19 are mitigated. So this statement A in symbolic is Q implies P. Is Q implies P, right? So when you when you look at here, the given statement is P implies Q, and question A is Q implies P. So relationship between this one, P implies Q and Q implies P, they are converse, right? They are converse each other. Therefore, for converse, the statement is not logically equivalent. So this statement A is not logically equivalent. In other words, the statement has no, and the content of the statement are not the same. Right? Are not the same. All right. Question B. Okay, question B. Governments governments will not have acted quickly. Governments will not acted quickly. This one is not. Okay, just now what is government is P, P. So this one is not P. Sorry, if see that the word if in the middle, that means not Q, not P implies. So this one is as what do you call this? Conclusion. This one is conclusion. So this is hypothesis. This one is hypothesis. This is conclusion. Okay, conclusion. So just now government. Government. Okay, so the government is P, and the effect is Q. Government is P, the effect is Q. Okay, government is P. So this one is not Q implies not P, right? Not Q implies not P. Yeah. Government P. Yeah. So this statement in symbolic is not Q implies not P. So this one is the contrapositive to the given statement, right? Therefore, B is a logical equivalent. This one is logical equivalent to the given statement. Right? Okay, question C. Governments will not have acted quickly, or the government will not acted quickly. This one is not P, right? Or, right, the effect of COVID-19 will be mitigated. So this is Q. Right, the given statement just now is P implies Q, right? P implies Q. So P implies Q is equivalent to not P or Q, right? This is a formula. P implies Q is equivalent to not P or Q. So this one, we call it, it is logically equivalent. Right. So I hope you understand about logically equivalent. So next, question 12. Use truth table to prove that A or, okay, this one, this statement left equivalent to right. Okay. So using truth table, right, you should build the truth table. Here we have two statements, A and B. So A and B, therefore there are 4 rows. Okay, 4 rows. Next one, A or B. You have here A or B, and A and A or B. So this one. Then next, left, the whole part of left hand side. And okay, I just name it as P. Okay, here I use a biconditional A. So this, the last column, is actually optional. Okay, for equivalent, logical equivalent using truth table, either you use identical column or use tautology. If you choose to use the reason of identical column, right? So for biconditional, you can omit this biconditional. That means you can omit this column. This column. This one is optional. Okay, the truth value, I believe that you know what to fill in the truth values for this table. So the conclusion here, the truth values of first, look at this one, of first column, right? And fifth column, this column, are identical. Therefore, the statement, right, is logically equivalent. Are identical, so therefore it is, and you write this statement, right? Or you also can write the conclusion, the biconditional is tautology, therefore write this statement. Okay, number 17. Use logical equivalence to rewrite the following sentences. Either she is late and has forgot to call, or she is late and has had an accident. All right. To rewrite this statement, of course, first of all, you should define the simple statement. Here, P, I just write P, she is late. Q, she has forgot to call, right? And R, she has had an accident. So there are 3 primitive statements. Okay. So now next one, translate the given statement in symbolic. Either, use the word either, means or. She is late P, and has forgot to call. And Q, right, put bracket, this one either or. Okay, she is late P, and she has an accident, and she has an accident. All right, so this statement is equivalent to, can you see this, right, pn and then this pn, right? You can simplify, to pn, okay, open bracket, q or r, okay, pn, q or r. Right, inwards, she is late, that is for p. She is late and she is late and she has right, this, or you can use the word either, okay? And she has either forgot to call or had an accident. Okay, all right. Question D. It is not true that both I am wise. So translate P. Okay, assign in a simple statement. I am wise. Right, Q. You are a fool. You are a fool. Right. Translate this into symbolic. It is not true. So that means not outside. That both, the word both is referred to, and I am wise and, right, you are a fool. It is not true that both I am wise and you are a fool. So now to write the equivalent statement, right, of this one, you should open the bracket, right, not P or not Q. Okay, write in symbolic, write in words, this one, or, so I can use the word either. Either you are, either you are, either I am not, either I am not wise, or you are not a fool. Okay, right. Now this extra exercise from your future, the future that I put in content, content, yeah. So use the truth table to determine whether this statement, right, logically implies. So the symbol for logically implies is this symbol, logically implies to this statement. Right, let's construct truth table. Here we have two statement, simple statement P and Q. We just put here PQ. So what else? Not P, we have not P, and then not Q. And the statement, the first statement, not P by conditional Q, and the second one, P by conditional not Q. And after that, you combine, just name it as A and B, otherwise it's too long. Okay, A and B. So we finish, this is left part, left hand side, right? And just I name it is as C. So the right left hand side is not Q implies P. So I just name it as D. C implies D. You can see that C implies D. So this one, this last column is a must. You must show the last column. C implies, this is implication. The symbol for logically implies is double line with one arrow. But to show it is logical implies, we use implication. We use implication statement. Alright, so PQ, since it's two statement, so 4 rows, we have here 4 rows. So let's fill in the truth values for all columns. Not P 1100, not Q is 1010, not P by conditional Q, not P here by conditional Q. But this one 0, this should be 1, this also 1, this is 0. Okay, by conditional P and not Q, P and not Q. So here is 0, 1, 1 and 0, right? So this column and this column, the connection is N, so this should be 0, 1, 1 and 0, right? Not Q implies P, not Q implies P, implies, so 1 implies 0, this is 0, 0 implies 0, 1, 1 implies 1 is 1, 0 implies 1 is 1. Right. So now to take this column and this column, implies 0 implies 0 is 1, 1 implies 1, 1, 1 implies 1, 1, 0 implies 1 is 1. Can you see this? The last column is tautology, right? So you write the conclusion, since, right, the last column, okay, shows tautology. So copy everything, P by conditional Q and P by conditional not Q logically implies, okay, logically implies not Q implies P, right? So next one, construct a truth table to determine whether, right, this statement is logically equivalent. So for logical equivalence, we have two things, either one, you choose either one, whether you want to choose about identical column, okay, or by using biconditional. Choose one, okay, but here I show you all. So all right, let's fill in the truth values for all columns. Okay, not Q, it should be 1 1 0 0 1 1 0 0. Not R, 1 0 1 0 1 0 1 0. Okay, P implies not Q, P implies not Q. So 0 implies 1, it should be 1 1 0 implies 0 1. So this also 1 1, not Q, this also 1 0 0 1 2 3 4 5 6 7 8. Okay, so not R by conditional P, not R by conditional P. So this one 0 1, okay, 0 1 1 0 1 0 1 0. Okay, then A and B, I just name it as A and B. Okay, no need to copy everything, otherwise it will be too long. A and B, this one is the values is 0 1 0 1 1 0 0 and this 0, and both 1 will be 1. Okay, let's check. Okay, 1 0 1 1 0 0 0. Okay, right. So now Q or R, one value 1 will be 1. Okay, 1 0, this one give 1 1 1, we will give 1 0 0 is 0. Okay, 0 1 will give 1, 1 and 1. 1, 0, 3. 8, 1, 2, 3, 4, 5, 6, 7, 8. Okay. P implies Q. P implies Q or R. Okay, here this column. P implies 0 implies 0. You get 1. 0 implies 1 is 1. 0 implies 1. 1. 0 implies 1. 1. 1 implies 0. Give 0. 1 implies 1. 1. 1 and 1. Okay. Now next one is what? A and B. So this column, okay, this column biconditional C. This column biconditional C. This one you got 0, right? 0, 1, 0, 1, 0, 0, 1, 0. All right. So these two columns, okay, I will show you this both. I will show you both reason. Look at these two columns. Look at these two columns. Are they identical? They are not identical, right? They are not identical. That's one reason. You can write like this. Since column 1, 2, 3, 4, 5, 6, 7, 8, 8. Since it column 8, since column 8 and column, since the truth value, since the truth values of column 8 and column 8, 9, 10 and column 10 are not identical, so the statement, okay, you write, you can copy everything, this one, just write, so P implies not Q and not R biconditional P is not logically equivalent, is not, or you can write in symbolic, just put cross, P implies Q or R. Okay, that's one reason. Or you can write reason using biconditional. You can write this way. If since the last column, or you can write since the biconditional is not tautology, therefore this statement is not logical equivalent to this statement. Okay, so you understand that? So for that, this one is the last question that I would like to discuss. So for that, I end the tutorial class with Assalamualaikum warahmatullahi wabarakatuh.